Okay, ladies, so this is part 3, which I'm hoping is the final video. I've decided that I'm not going to go over example 8 in the video. I'm going to wait to go in class because it's sort of a different concept to think about. It's still involving power series and along the same lines, but it's asking sort of something different. And I think the power series, what we're going over, the IOC and the ROC, I think that's enough for you to digest for Friday and then work on the fun sheet that I have for you planned for Monday. Okay, so let's look at this question. For which values of x does this series converge? So this is worded differently than the other questions, but hopefully you know what it's asking for. So for which values of x does this converge, this power series converge? So it's asking us to find the IOC, it's just worded differently. So just keep in mind in mathematics, you know, things can be worded differently and ask you for the same thing. All right, so it's asking for that. So take a minute, pause the video, and actually set up and see if you can get down to where you would see maybe your ROC. Okay. Okay. So I decided to not go all the way through and write the complete answer because this one you have to be very careful with actually. But hopefully your setup was the same. So hopefully that line, that first line there, you guys are good with, right? Then you go ahead. So once you simplify your a sub n plus 1 over a sub n, then you set up, so rho is equal to the limit as n goes to infinity of the absolute value of n plus 7 times x. We know that since n is starting from 0, we know that that n plus 7 will always be positive, so we can take it out of the absolute value. And so we have here the limit as n goes to infinity of n plus 7 times the absolute value of x. Okay. We also know, and I guess I should have put that here. So from here we can say, well, no, we don't have to say when, but we know it's going to converge absolutely when, if I can write the limit as n goes to infinity of n plus 7 excuse me, times the absolute value of x is less than 1. Okay, so now we have to be very careful because I know you just want to say, well, it's going to go to infinity, which is greater than 1, so it's going to diverge. It's going to diverge for everywhere, right? But always keep in mind there is at least one interval of at least one point that will converge on your interval. Namely, the trivial case when it's as x is equal to c, right? And so in this case, c is what? 0, right? Because there's no center there. So keep that in mind. So it'll never be a case where it diverges everywhere. It will never diverge everywhere. At the very least, your power series will converge for the trivial cases where x is equal to c. So it will converge at least at one x value. Okay? Here, so that's the first thing to keep in mind. The second thing to keep in mind, which I wrote down, is remember this limit only goes within. And so if it only goes within, x is independent of that limit. So you may be thinking, well, if x is 0, then you have infinity times 0, which is an indeterminate form, but it's not because, again, x is independent of n, and the limit, when we talk about the limit, we're only talking about n. So in all the other cases, up until now, the other cases with infinite series that we've been talking about only involved n, right? It only involved our n, and so when we took the limit, that's why we had those indeterminate forms. But now we're involving not only just n, but x, our variable x. So the limit only goes with n, all right? So keep that in mind. So keeping that in mind that x is independent, totally independent of n, then the question to ask yourself is, well, can rho ever be less than 1? Because that's where you're going to have your series converge absolutely, when it's less than 1. And the answer to that is yes, right? When x is equal to 0, because you won't just get, I know you, and it's sort of intuitive to think about it, but just keep in mind that that n only goes with the limit only goes with the n. So if you only think about that, then no matter what you know, as n goes to infinity, n plus 7, we see that's going to go into infinity. But since x is independent of it, when x is 0, that 0 will dominate and make that entire thing 0, right? And so it's just when x is equal to 0, which is the center, right? It's a trivial case. So we will conclude and say, thus, our series, n goes from 0 to infinity of n plus 6 factorial times x to the n, converges when x is equal to 0. And although it didn't ask for it, that's, if I asked you what would the ROC be, you would say 0, right? Because it's not going anywhere. It's only at that fixed point. I hope that made sense. Go back over it if you're still not clear on this. And if you're still not clear after you go back over it, please, you can ask me about it more in class when I return on Tuesday. Okay, so the last problem, I know you guys are excited about that, of the video is example 7. Again, so I want you to go through and, so it's a series, n goes from 0 to infinity of -1 to the n times x plus 1 to the n over 2 to the n. So I want you to go ahead and set it all up until finding the IOC and ROC. So pause the video and then solve it up until finding the IOC and ROC. Okay, so by now you should have did this problem out. I'm not going to go over everything. You can look to see what I did. Using the ratio test, making sure, so make sure you simplify correctly, and then once you get down to, once you simplify, you find your row, which is the limit as n goes to infinity. Notice that there's no more n's left, so you can just drop the limit, and so you have 1/2 times absolute value of x plus 1. We know that's less than, solving for that, we're not solving for it, we know that to converge absolutely, we want that 1/2, the absolute value of x plus 1 to be less than 1. Multiplying that by 2 on both sides, you get the absolute value of x plus 1 is less than 2, and therefore you have your ROC. And then during the work, you see that your possible interval of convergence is from -3 to 1. And then you have to check your endpoint. So, and I skipped steps in checking endpoints, so make sure you understand how I receive that. If you need to add extra steps, that's fine. To save space, I skipped some steps. And so therefore our ROC is 2, and our IOC is from -3 to 1 because they both diverged at the endpoints. Okay, so we're almost done, but I want to quickly revisit example 7 because I don't know if anyone noticed it or not, but everything is raised to the n in this problem. So this is an example where we actually could have used the root test, and let's see how. Okay, so here is by the root test. So recall that's the root test formula we went over in class, and then you can check to see once you simplify it, you'll get the absolute value of x plus 1 over 2, and we know that will converge absolutely when this is less than 1, which means that is less than 2, and we're back to the last slide that we just did using the ratio test. So again, as you can see, we can use the ratio test. The ratio test had more algebra in it than doing the root test. So the root test, when you can use it, meaning when everything is raised to the n, that's when the root test will be more convenient. If there's one thing that's not raised to the n power, you cannot use it. And it's the n power. Be very careful, because I remember last time I taught this, students were getting confused and thinking if they had, you don't have to write this down, but thinking if they had the square root of n, then they know that's n to the 1/2, and they thought, well, maybe I could put in, well, no, maybe not. That's not a good example. But if they had, what was it? Yeah, they had something like n to the 1/3 in their series, and it's something else, then they thought they could use the root test and just put the third root of n to the 1/3. That stays fixed as your n or your k, right? You can't change that, okay? So if it's not raised to the n power, if it's not some 3 to the n or even n to the n or -1 to the n, if it's not in those formats, then the root test, although you can use it, you're going to have trouble because you're not going to be able to get rid of the root in a lot of those cases or get rid of the term. So hopefully you guys understood this. Go back over the videos. We are done. Once you look over these videos carefully, you can start the quiz. And yeah, just make sure it's due by midnight. Also, too, let me say this. In Gradarius, if you're using, like, I think for ratio root test as well, although I didn't put any problems, which you'll have some from the quiz, there's action terms for, I know for alternating series, P series, there are action terms. So you can just click, highlight the series and put series, and the test should pop up, and then that sort of will guide you in the steps. Because I know a lot of you talked about that you couldn't use words in Gradarius, which you can't, because I just want to see your work. So when you're thinking about, submitting your work, just think about, how can I show this and make sure the steps are clear. And you don't have to show necessarily every step, but how can I show this to make it clear without using words, because you cannot use words in Gradarius. So just keep that in mind when you're submitting your quiz this weekend. All right, ladies, I will see you all in class when I return. Take care.